Almost done. Okay, we are live. Welcome everybody to the Node.js Security Working Group. Currently, we have 3 items in the agenda, and let me cancel my echo. And here's the minutes. If you can put your name there. So the first item, before we continue, anybody has any announcement? I think no. Does anybody? Okay. So the first item in our agenda is the security model. The issue 799. Basically, this issue is just to keep tracking of the document that we are building. And the document, in the document, we have several questions. But before going on, I have some agreements requests. The first one is to rename this document to threat model instead of security model, because we are considering it at least the structure that we defined. We have defined in the last meeting was mostly a threat model, not a security one. So just would like to get an agreement on that. What do you guys think?
I'm happy with the renaming.
Sounds good. I think, I like looking at the example that Facundo added. What do they call theirs in that other example, just to see?
So that document is contains a threat model where they actually say which part of the software the software itself is required to secure and which part the user is required to secure.
Right.
And then afterwards you have the part where they discuss the design considerations for the software, which is not strictly part of the threat model, but can be included.
Yeah, I think in that context, like that's just another data point where the content is really more threat model versus. And that's a great starting point. So yeah, I'm makes sense to me. Okay.
The only drawback of this might be that if we want to put something in there that's not exactly a threat model, it doesn't fit into the structure, we're gonna have to spawn something new. But yeah, it's just a name that means more than just a title of a document.
Yeah, just to summarize, in the last meeting, in the previous meeting, we have defined that this document that we are looking to aims to show the threats and the mitigations, but it's not like a tutorial. It's just say that, oh, Node.js does not provide a security or a security feature for that. But instead, we are willing to create a new document that it will serve more as a tutorial. For instance, Node.js does not provide a feature for that, but you can do this to mitigate this issue. Or at least you can secure your HTTP applications by checking the header and so on. So just renaming the threat model here. Okay. So regarding the document structure, I think that we have a lot of people here to discuss better. But just to summarize, we have defined it is not right in stone, okay? But we have defined the structure, like we have the environment, and for each environment we will have the threats and its mitigation. But I would like to hear Facundo. He's doing actually he have great knowledge in building threat models, documents at least, and I would like to hear him to at least to some explanation just to check if we are in the best path. But before going on, I have researched two other language reference for security model or threat model. And here is the threat is the Dino one, but the Dino doesn't provide much information. Let me send it here. Okay.
Are you pasting it in the chat or somewhere else?
Chat, in the chat.
Okay. There you go. Okay, thanks.
And this one is for Ruby. I feel basically the Ruby is like a manual. It seems very close to what we have defined previously, and I think that we can use it as a base, but yeah.
What I really like from just a very quick look at and where was this? Sorry, the one that Facundo pasted into was that the like, we trust X and we don't trust Y. I don't think that necessarily changes the structure that we have there, but like putting that in there somewhere in the introduction, because I think that helps. Like when I read that, it's like, I can see how that relates to our vulnerabilities, right? Like we trust the code that you've got locally. So if you're telling us that code does something, well, we trust it, so whatever. But, yeah. But I know we don't trust web servers that we're connecting to, and we don't trust clients that connect to us as a web server. And that's like, those lead directly to, like, if somebody can connect to us and trigger a denial of service, well, we don't trust them not to do that. So that is a vulnerability, right? And similarly, when we connect to a server, if they can somehow configure their server, to do something, maybe that's that one, maybe we're choosing anyway. But having that list of like who we do and don't trust sort of resonates with me. So having that in there as you go through each of those, like spoofing, tampering, whatever, it gives you the context of whether you think you need to protect against the person who could do that or not.
Yeah, there's a section in this document, Kel, what can and cannot be considered a vulnerability. I think it's what you mean, right?
I think even though when you've got that spoofing, tampering, if we're going to go through that, I think before that, it would be good to say, here's what we trust and what we don't trust, because it will inform, like if somebody says, I guess it's like, in the context of those, we're going to have to get into like, well, how do you spoof or how do you tamper, right? And like, say for tampering, if it's local code and we've said we trust that code, then it's not an issue. Whereas if you can somehow tamper remotely, it might be, right?
Yeah, so in general,
go ahead.
What can be considered a vulnerability comes, or is a consequence of what you trust and what you don't. So I think there's value on defining that first, and then you can be more specific, more inside the document, and then go through like examples of vulnerabilities that are not actually nodes problems. But yeah, I think it's good to start with that. And I really like the fact that you separated for different environments. I was wondering, how does the threat model change in different environments? Let's say between a local system and a containerized application. Is the threat model that different between those two?
I would say there's even more cases to consider, because Node has various use cases that are completely different, like IoT, for example, or just CLI commands implementations. And if you get a denial of service attack, it's going to be completely different impact depending on the use case. For a CLI, denial of service is not a problem. And if we have a denial of service in the core for a container running somewhere, or even worse for IoT, that's going to be more serious.
Yeah, okay, that makes a lot of sense. Then what I would do, at least in the document, is define those places that might or might not be potential threats, or vectors, so like the CLI at the beginning, even though in some environments it's not as bad as in others, and then afterwards goes like through examples of the different environments because that is very useful, but at least to have like an overview first.
Right. I mean, I think what I was hearing, and I think was kind of what I was thinking, is like the threat model may be common, but then in each of the different environments, the severity might be different, as ZB was saying. And actually, I think what would be useful for us is like to say, okay, here's the threat model, and then map it into each of those environments. And in some cases, you know, like the trusted code, well, we expect that to be mitigated by the end user who's putting the code in, right? Like, and in each of those environments, it may be that you need to address them in a different way. But I'm not sure, like in terms of, I guess where I was wondering, like it may be that it's the same for Node all the time, but like we want to explain in this context, these matter or don't matter. And do we expect Node to protect against them, or do we expect you to be doing something in that environment to protect against them? So, yeah.
Yeah, indeed. And in that last case, you can just link the user to that document Rafael was talking about, like the best practices for users to protect against the things that Node doesn't.
Yeah.
Like it might be that a section which is like the threat model in the context of these environments would be interesting, right? Like you paint the threat model, we trust code, we don't trust this, we trust that. Okay, what does that mean in this environment? What does that mean in this environment? And so forth would be, yeah. That way people could sort of look at it and say, oh, okay, well, I'm doing IoT, or I'm doing a web server, or I'm doing, you know, and how does it apply to me? And yeah.
Yeah, I think that what you are saying fits perfectly what we are doing right now. I mean, as you can see in the document design, we have two subsequent topics. That is, the first one is global information that Liran asked, but they are information that overlaps the environment. For instance, sandbox, regardless of the environment, the sandbox statement remains the same. So Node.js does not provide a secure sandbox. All the code is trusted to not be malicious. So I think that this is what you meant, right? We list all the statements that that Node.js was designed, and then we go further to environments and then threats and its mitigations, right? So we can at least rename it to a better name.
Yeah, like what I wonder a little bit is whether it should be by, like sandbox is almost the solution. So I'm not sure, like in the threat model, it's more like untrusted code. You know, we trust the code, therefore we don't provide any mitigations like sandboxes or something else, right? Like that's expected to be external. So it's not, you know, it's not that because that's sort of predisposing the solution to the problem, where we really want to say the risk is code, we trust that code. And so like, for example, if you're deploying a server in a container, the expectation is that the container is giving you the protection, which in which case is a sandbox, but there could be other ways of providing that same protection, right?
Yeah. So let me refer. Node.js trust the code is running. And there is one question in this section about the VM module, is sandbox or not, but it was previously discussed and it was defined. The VM does not provide any security mechanism for like environments or any sandbox at all.
Yeah.
Okay, next one is the permissions. Let me see one thing here.
I think that just kind of fits in the same thing though, right? Like we trust the code, and permissions are just another way to try and limit what the code can do if it's untrusted.
Yes. Yeah, I think that makes sense.
So I think like it's another, like you've got a few clarifications. It's like we trust the code. oh, by the way, you may be confused because you see a VM module. No, that's not a security mechanism. 2, we don't provide permissions to control what the code can do because we trust the code, right?
Okay.
Yeah, the same way as we ask the users, to sanitize the input or things like that, no? So the same goes for the permissions. Like you're supposed to know how much do you trust it and how to secure it, but this by the end user, right? So that's the approach with the permissions, similar as sanitization.
Let me adjust a comment. I will do it later. Okay.
I'm just putting in another example.
Okay. Yeah. So any HTTP library with can at least, I don't know, close HTTP server is not expected. Yeah. I have changed the permission, so if you refresh the page, you'll be able to edit it instead of adding suggestion.
Okay. I'm okay with adding, like, because we can see the suggestions too. So either, but
actually, there's one question regarding permissions. As I was talking with Bradley, he said basically that policy is a way to restrict permissions, to restrict, to prevent access to a few modules. But I wondering if policy is a proper way to restrict permission scaling. Honestly, I haven't used it enough to make a point here. I feel that would be possible. However, it's a tough operation because I mean, you can restrict a module to do a HTTP, but at least you might want to restrict just I don't know, this net inbound instead of outbound or something like that. So I feel that policies can restrict kind of permission scaling, but I don't think that it will be used at all because it is not granular enough. What do you guys think?
I think for the model, like the problem is like it's very difficult to get those permissions so that they actually like lock things down well enough to say, because you're basically saying, no, we don't need to trust the code. So I don't think we don't have anything which gets us to the point where people are going to say, hey, you can run untrusted code and these permissions constrain you well enough. I think somewhere else, so I think we would, in my mind, we should be saying, we don't trust the code. There's these, so the VM module isn't something that allows you to run trusted code permissions. Again, we can say there's an experimental permission support, but again, it's not at the point where it allows you to run untrusted code. It's more of an experimental area where we're trying to explore what could be done. And I think in the end, we might come up with something like, even when the model, it's like, it doesn't allow you to run untrusted code, but like if you want a little extra safety net, maybe it's good. It's just really hard to figure out, what do you say? Like, well, it doesn't actually solve the problem, but it gives you a little bit of like a safety belt. But then do people expect too much from that safety belt? So through the first pass, I would try and sort of stick to the message of, we trust the code, and we don't actually provide anything which lets you run untrusted code. And somewhere else we can say, hey, there are some experimental efforts to try and explore features that might change that, but that's not the case today.
Okay, ZB?
Yeah, so I think about policies. They could be useful for as a mitigation for supply chain attacks. If you're running code that you trust in general, but you want to limit the outcome of what could happen if part of that code got taken over and replaced by something malicious, then setting up a policy to not allow network if your app is never using network makes sense. Same with disk access. But these are very coarse methods of preventing anything. And I think this is where I'm coming from, by the way. It's so full disclosure, I'm working with people pushing that in TC39, but there's a compartments proposal which we should be interested in, where you can put potentially untrusted code in a compartment. And for now, compartments are similar in functionality to the VM module, but they give the opportunity to make it much tighter. And then additional steps after compartments will lead to introducing the full scope of secure ECMAScript proposal. And only then it is possible to limit what the code could access. So first step to get interested in the compartments proposal. I think it's worth bringing up on some meeting later.
Okay.
And I think we, like in the deep dive or on the security models and stuff, next 10 deep dive, I think that fits in with like what we said is we do think that's interesting, but we're at the stage where it's more like we're experimenting, we're seeing what can be done. And I think things like standards and it being in TC39 will help that a lot, because it's a really complex topic to get something that is either like provably correct and will give you real protection, or enough that it's like, even though you know it's not perfect, it adds value. So that, I guess, a long way of saying, like, I think if there's a standard, it helps us be much more comfortable that like, hey, we've provided this standard, and whatever that gives you, whether it's 100% or less, is a reasonable thing, right? And I guess what I really just wanted to say was, and that we should maybe somewhere in here, if we're saying like, yeah, we don't provide this, but the project is interested in experimenting and supporting the experimentation on that front, right?
Bradley is in the panel, in the attendees. He want to talk, just promoted. Okay, Bradley.
Howdy.
Hello.
Oh,
I interrupted people. Michael.
No, I'm done. Sorry, go ahead.
Yeah, so there is a long history of secure ECMAScript in TC39. I don't know if anybody else has followed along. I know Dino talks about it a lot, but they have not participated in any meetings to my knowledge. There is a weekly meeting. So I'd be very wary of compartments just because there's a massive pushback by Google in particular. And we've tried a few things from Node to talk to Google about this, particularly about globals. So the compartments API is not going to have the same functionality as the VM module because Google doesn't want to introduce new global contexts, is the big pushback. And that means prototype pollution, etc., will still be possible with it, which are the main source of CVEs these days.
that was probably meant to be fixed by freezing intrinsics. I mean, partially, and then lockdown, which is part of the overall SES proposal. I don't think compartments themselves were supposed to solve the prototype pollution and fiddling with globals.
Yes, we already have frozen intrinsics in Node with the frozen intrinsics flag. You definitely cannot turn it on by default because it changes a variety of behaviors in odd ways. Most things work though.
So regarding the policy, we just say that policy can be a way to restrict permission scaling, for instance, but it's still experimental. And I think that for this document, we can just say that Node.js trusts the code being run, and we don't provide any feature that allows you to run untrusted code. And in the second document, which we will create a tutorial like mitigations, we can mention the experimental standards, experimental work that we have been doing in Node.js to mitigate, and the end users might want to try. So does that make sense to you?
I mean, for a security model document, that seems a bit odd, because you're basically saying we won't be protecting if you're talking about the model. It is, you need to declare in the model not the mitigations themselves, but an intent to mitigate. So yeah. So
yeah, so the model, as I understood it for this document, is the purpose is to actually make it clear which parts are being considered safe and trusted and which are not, which is, I think, what you just said. And then there will be a separate document with best practices or mitigations that users can do in order to do what they want with the untrusted parts of Node security.
Yes, but to be clear, the security model is not a statement about the current state of things generally. Usually when you create a security model, it is about what the attack vectors you accept as threats are and what you intend to mitigate.
Right, and I think in the context of this is like, we trust the code. We don't intend to mitigate anything that is, you know, hey, I'm running untrusted code, right? We may change that in the future based on the experimentation, sure, on the things, but today it would be like, no, sorry, the code is trusted, and that's what we accept the vulnerability reports on.
Correct. You just need to include that it is untrusted code. Node may bring a trusted code mechanism, because right now the original statement was all code was untrusted, which is very different.
Right, but today I think, like, based on our security model, we would still assert that all code is untrusted until we graduate some of these other things, right?
That's not,
yes,
that's not in the model. You wouldn't put that in a security model. That's like an audit. That would be an audit report. Is this supposed to be an audit or a model? Because the model is going to be talking about future mitigations. You don't have to have the actual solutions, but an intent to prevent a attack vector is going to be in the model.
Yeah. But is there a concrete plan in the future to mitigate against untrusted code, or?
You don't usually need a concrete plan. You're stating that a threat is going to be a threat. It's accepted as a vulnerability.
Right, but I think today we're saying we will not accept, like, it's, we've agreed we should experiment and explore things like permissions and stuff like that, because it's important. But I don't think there's agreement that we will ever, you know, hopefully we get there, but I don't think we would be putting into our model that we will address those vulnerabilities. We will update the model when we can, and if we get there, but today it's like, no, the code's untrusted. That's what the way you should be thinking.
That seems both good and bad. I agree that we don't have to state we will mitigate it, just that these are things that should be mitigated by someone if you do them.
Right, in the context of the second steps, where we said, like, in this environment, you know, I think we would be saying, for example, that, like, okay, because you're running untrusted code, you know, the that is partially mitigated, say, because you're running in containers, right? And discuss in that second section of the environments that the environment is intended to provide any additional things that you should be doing, or that, you know, we recommend that you scan your modules, or whatever those kinds of things are.
Sure, but that would still be under the accepted threats in the model. Like, you don't need a solution. Like, that's the big thing with security models. That's, if you go and read a bunch of security books, you don't have solutions in your model all the time.
I think
Especially
we
if
want
it's
our
new.
model to be clear in terms of, like, if you report this, if you report something that says I have untrusted code, we are not going to accept that as a vulnerability today.
Sure, that's fine. But you're talking about running code for another user and what they need to mitigate, what their responsibility is. Saying everything's their responsibility is not a useful document.
Right. So we're going to say what we do, like, so for example, we do, you know, we trust the code. Therefore, if you've got something that doesn't trust, that relies on trusted code, doesn't fit our current model, we would say,
Correct.
We
Yes,
don't trust,
that is what we need.
you know, we don't trust HTTP clients connecting to us. So if there's an attack that says, you know, you can connect to node running HTTP and you can cause a denial of service, that's generally when we say, okay, yeah, we're gonna accept that as a vulnerability and address it.
Yeah. So that is all I'm seeking, is listing the actual threats, not anything, just basic statements of, since we treat all code as trusted, it is your responsibility to mitigate if you require trust in your code.
Yeah, I think we have that in the outline there. It's the, like, code is untrusted, and we can say, like, yeah, I think you're maybe asking that we add the extra line that says, you know, if that's a concern for you, you need to mitigate it yourself.
Correct.
Yeah.
Because right now, if we just state that all code is trusted, that doesn't give any action for somebody reading the document to take.
Right.
And
yeah,
the
no, I think
action
that's a good thing to have
bad.
there.
The action can be kind of vague or terrible, any of that, that's fine. But we are moving the responsibility to the party reading this document.
Yeah.
So we need to give them some way to act.
Yeah, and I think that in that situation, like, if that's a concern for you, mitigate yourself, and we can just provide a list of the mitigation, global mitigations that we can that we are working on. Like, policy is a thing, you know, just even experimental, but it might work for the use case, and like the flags. I think that we can just add the list of potential mitigations to this statement, right?
I think that needs to be really careful. Like, I would include that under, we're exploring techniques that may allow us to change this, such as blah, blah, blah. But today that's not the case. I think what Bradley's talking about is, like, in those environments, and I think maybe, I can't remember if it was Facundo or Zigbee mentioned, was like, in those other environments, we can list best practices. So we can say, like, in, you know, in a container or in a server deployment, we, you know, best practices to run in a container, and to, you know, which controls what file systems it can read and write to. You can control, you know, the incoming HTTP, you know, so that's the kind of thing, that's the place where we can list external mitigations of some of these things, right?
Yeah,
sure.
But to make it very clear that, like, these are outside of Node, so, you know, it's not, we don't want to get back to the, we don't want to confuse people in terms of, by pointing to the things in Node that might help, when we're not at the point that we're saying they are the solution, right?
okay, yeah, absolutely. I mean, the user might can read it and consider that it is a mitigation totally, but it's just, yeah, okay.
Whereas in the environment, we can say like, okay, you're deploying to a container, best practices to configure your container in some way. I think somewhere we can also get in like best practices to run what kind of security audits or whatever, you know.
Yeah, totally. Okay.
You know, I think then the environments is probably a good place because best practice may be different for each of those environments, right?
Yeah. Okay. So, okay. So there is one thing that I think that since we just started, we can would be great to start the list what can and cannot be considered a vulnerability in Node.js. I have been working in a few HackerOne reports, and I have collected a common report that were not considered a real vulnerability. Instead, it's due by Node.js design. So I have added to the list the module resolution algorithm as a threat, but actually this is how Node.js works. But I don't think that the name module resolution algorithm as a threat is a good thing. I think that we can rename it to a more generic way that can fit to several use cases. For instance, if you try to load an npm module and this module is not found in your node, in your current node modules, it will follow the module resolution algorithm, and then it might find malicious malicious folder called node modules in a shared path, for instance, in the Linux. So it is not considered a vulnerability in Node.js, but I don't know exactly a good name for that.
So the enumeration would put that under probably uncontrolled search path element or untrusted search path. So CWE, not CVE, has a bunch of generic names that these fall under. Be good to just reference those.
Can you repeat, please, the name?
I'll just link it in Zoom chat real quick.
Okay. That's good.
But you have to narrow that down. Usually with CWEs, you have to be specific about what it is. So you would mention uncontrolled search path. These are the actual things that you're treating as threats under that.
What are you saying, Raphael, that those were things we did consider vulnerabilities or did not?
We did not. We actually, the idea is to list threats in our threat model, and then explain a bit how Node.js works and why it is not considered a vulnerability because it's designed by Node.js.
So we have to be careful at least on that one. We have a CVE on that one. So, yeah.
Like I was thinking, can we map that into, you know, we trust the user to configure the file system in a way that is safe for the Node.js module resolution algorithm?
Yes.
As documented in X, right?
Sure.
But in this case, the danger is coming from someone manipulating the file system, not the path that was given to the require function. So is that
so could we say
thing?
Could we say that we trust the file system and then that one of the threat actors is someone with permissions to modify the file system in a malicious way?
Yeah, we trust the file system. Yeah, we really trust.
We trust that everybody who has access to modify, we trust everybody who has access to modify the environment, right?
Yeah, we don't provide the security mechanism based on users. I guess. In that case, Linux users like, and its own path.
I don't know, I'm just writing stuff down, but like that could be like, we trust everybody who has access to the local environment.
Okay.
We're getting in depth on specific topics, and I wonder if the information architecture of the document has been settled, because initially we discussed that we should have a list of threats and then assign them severity per environment and discuss how they can be mitigated per environment. But that suggests an information architecture where the document starts with the top level item being the list of possible threats. That's not divided across environments, because the same threat, as we discussed, should appear in all of the environments under a different severity.
I think I still like that, except that maybe what we're talking about is that, like, before the threats, we should list what node trusts and doesn't trust. Then you can go into the threats, and when you discuss each of those threats, like, you can then list the threats that apply, and then we could go, I don't know whether it's in the environments or whatever, but like we can say, because of what we trust, this threat, does node mitigate it or not, right?
So I'm trying to figure out if we're going to put threats, a copy in each environment, or are we going to have threats and environments as something that's nested under a specific threat or as a separate part of the document? So strictly information architecture here.
So
go ahead.
So one suggestion I might have is, even if you have threats listed under each environment, which seems reasonable to me, if you have the mitigations as an entirely separate thing, you can link to them from multiple environments, which would be nice. So mitigating on OS X versus Linux, they could probably, for a lot of things, point to the same mitigations.
Yeah, actually, we weren't even thinking OS X versus, like, we weren't thinking OS platforms. I think, like, environments, we were more thinking,
IoT.
you know, you're running a IoT, or you're running a client scripts versus deployed server.
Even if it's not OS, it doesn't matter. The mitigations might be shared.
Yeah, no, I agree that that's a good, like, there could be a sections mitigations, and then in the environments, you can point to, like, in this environment, these are the mitigations which are best practices, right?
Good point. Let me create the section. Mitigations. Okay, I think that we are in a good path. Okay, we renamed the module resolution algorithm to a better name. And there's one thing in the start of the document that is, I mean, I was looking to Bradley documents, and I heard about strides. So I researched briefly about strides, but if someone has more knowledge on this, please correct me if I'm wrong. But basically, it derives a threat model documenting into 6 categories: spoofing, tampering, and so on. So it answers the questions: what can go wrong with my application, with the Node.js application. So so far as I understand, all the threats should at least violate one of these categories to be considered a real vulnerability in Node.js. Is that true, or am I missing something?
I mean, you can fit almost anything into those categories. So for example, integrity falls under denial of service. Or yeah, for stride, it's under integrity. Yeah.
So basically we don't need to mention stride here, right? Because at least it's like it seems useless.
It's useful for people reading the doc just to have an understanding of what you're doing. Because like you said, people might not know it, and they might come with really wild things where it falls under like 4 categories in order to achieve it. Usually with stride, you're trying to narrow down any sort of attack that you're going to mitigate onto one of those.
Okay. Okay. Sounds good.
So if somebody comes off and it's like, it requires spoofing and tampering, and you've mitigated the integrity of the application, that's a really hard thing for us to address as a threat. If you got rid of one of those, the whole threat might go away, most likely. Yeah.
Great.
I was just thinking, like, if we look at the bit of the structure, I think we're talking about, like, we start out with what does node trust, not trust, the threats and applicability categorized by stride. So that's where I think when we have that section on threats, we can categorize them under, like, stride could be the top level headings. And then we might use the CWEs underneath there as to further categorize them, right?
Yep. Another thing that's pretty common in security models is list of assets. That's what we're going to be calling generally the outside inputs. So an asset might be environment variables, command line flags, the file system, and stuff like that, so that people know what is in scope even. But that would be a very long list for Node, so you might not want that.
Is there a
few other documents?
Like, is that something that would there be a common set for like any application that we could refer to for that?
There is. I don't have time to dig it up because it's not around. I've got to go to a doctor's appointment in a minute. But yeah,
is
there's
that something you think you could find?
You could just look. You can just look them up on Google for like security model assets, runtime, and find some.
Okay, just
Okay. The document structure, I mean, I think that we have it well defined. We don't need to discuss it even more. If you have any further questions or suggestion, you can add to the issue in the security working group. But if you want to have a synchronous communication like instantaneously, you can chat in the Node.js security model channel that it will change to threat model. So just to summarize, we decided to change this document to threat model instead of document model because it fits better what we are doing right now. And for further, if you have any potential attacks, at least let's focus in local systems. So until now, just put in the document. We can discuss in the next meeting. I think that this is all that I have planned to this meeting. Actually, we have discussed just this issue, but there's another one, but I don't think that we will have time to discuss the permission model and also the automatic check for dependencies vulnerability in Node.js CI. I just would like to give Facundo talk about his issue because the permission model, the state doesn't change. So that's it. if you can just provide a bit more information about this CI, would be great, Facundo.
Yep. So the idea is I've been working on a script that automatically queries for new vulnerabilities for Node.js dependencies. So for example, Node depends on a number of C++ libraries and JavaScript packages, but there's currently no automated check for new vulnerabilities that those dependencies have, right? So the idea is to have a script that from the Node.js repo reads the versions of each dependency and then queries known vulnerability databases with those dependencies and those versions and reports if there are any new vulnerabilities reported for the dependencies. And then you can have that as part of a CI action, which you could then fail if a new vulnerability is found, and then the maintainers could quickly see and update the dependency or react quickly in general to the new issue.
Okay, yeah, that sounds good. But when it finds a vulnerability, what actions should we take? I mean, it will create an issue or?
Yeah, so that's a good point. I would say it's the same process that you follow when someone reports a vulnerability against one of Node's dependencies. In this case, you can also get false positives because it could be a vulnerability that affects a dependency but doesn't actually affect Node by the way Node uses the dependency. But yeah, I would say to follow the same, so have a CI email sent out to the maintainers, and then the maintainers themselves can take a look to the issue and see if it requires some action like updating the dependency, or if it just can be ignored, and there will be an ignore list on the script that you can just add vulnerabilities to, and then those will be ignored on future checks.
So this sounds very familiar to me because where I worked at the time, I introduced the Node security project check before it became NPM audit into the CI pipeline, and that quickly led to having to come up with an entire piece of software to manage what we ignore. So the idea to, instead of breaking the CI, to report that as an issue and make the issue a permanent record of it, including the decision to ignore it, seems like a good choice if you can make sure that the logic is there to not duplicate the issues. Then ignoring it is, well, doesn't require implementing. And if you're actually implementing ignoring something, there's a lot of complications involved, which I happened to implement in NPM Audit Resolver, which is a wrapper to NPM Audit, where if you decide to ignore something, a package found in your dependencies, you actually need to ignore it along the path, because otherwise the same package or something that happens to be called the same could end up in your dependencies where you would no longer ignore it. So you have a dependency for your CLI that you use as a dev tool. You ignore a denial of service in that, and then someone uses the same package as their dependency all of a sudden in your nested dependency that you use in your server code, which then becomes a problem. So ignoring is not a flat list. That's what I wanted to say. And implementing ignoring as ignoring an issue, which we're all experienced doing, sounds like a good idea.
Okay, but then
sorry, go ahead. I think the balance though is if it's too easy to just ignore something, we'll also just ignore and you don't get the value. Like if the thing is always red and it requires everybody to look at the result, then does anybody look at the result ever, right? Like, so I get your point, but it's kind of like the balance between, you know, if we actually say, okay, we're ignoring the CVE, you know, maybe it's like the CVE is reported against this particular dependency. You know, is the risk of like, okay, something else, meaning that we shouldn't ignore it, bigger than us just never looking at the results in the first place?
I assume we would look at the issues as they pop up. And the only thing that's better in terms of forcing people to look at it would be to crash the CI and, you know, put it on the critical path, so you won't get a release if there's a known vulnerability, which means we're going to need a very good mechanism for ignoring things. And I even remember introducing means to ignore something for a very short period of time where you need to release something. Imagine we have an urgent security release, and then there's a bunch of unlikely to affect us but not researched new vulnerabilities. Do we want to stop the CI with those?
I think we're very far from we would ever actually block the CI. I'm more like the balance between awareness, and you could be right that like just a new issue that we get messed with, that we get commented on, is just as good. So, but that's the, like, in my mind, it's like making sure that we don't make it so easy to ignore that we just don't notice new things versus, you know, the CI being read. But I guess if it automatically generates a new issue, then, you know, maybe that is visible.
Yeah, and it could mention a group or a few groups for triage initially.
Right. Yeah, and maybe I mentioned, like, you know, both the security group who's interested and, say, the TSC who should be interested, right? And actually even like an app mention for, you know, if we look at NPM, the people on the NPM team who can hopefully provide some insight as to whether it's an issue or not, right?
So that depends vastly on the thing that we're actually checking, because it's not just NPM modules, it's also at least Facundo mentioned also C++ dependencies and a bunch of other things. So the people who are going to look into it and the method used for looking into it are going to be different depending on what it is.
Right, that's what I was thinking. We'd want different app mentions for each component.
Yeah.
You'd like it like create an issue, and for this component app mention this list of people would be a nice.
Okay, guys. I think that we ended the meeting.
Yep.
Thank you, everyone, for the participation. It was very productive. And we will see everybody. I hope to see everybody in the next 2 weeks. I will create the minutes. I will read the entire live again to create a valid minutes for the folks who weren't able to participate. So see you in 2 weeks. Thank you, everybody.